I think our North Star is that when people download Session and use it, they should be out of the box provided an extremely high level of privacy. So that means
today I have the honor to bring on Kee Jefferys from Session, who's going to be very pragmatic in talking about the pros and cons of their decentralized messenger, which is commonly compared to Signal. I'm going to ask them why they route to servers all around the world. I'm going to ask about the history, perfect forward secrecy, and a few more technical things. And Kee's going to go ahead and give you all the answers and hopefully educate us along the way. And now Kee from Session. I want to welcome Kee from Session here today. And I want to start by just asking who you guys are at Session and what makes you special.
Yeah, so I'm the CTO at Session currently. So I work on the tech side of Session, try to help organize some of the vision and some of what the team that is in Australia that's working on Session does. So in terms of what Session is, it's an end-to-end encrypted messaging application. Typically, because your audience is quite technical, I won't I'll try and be technical as well. The things that we kind of focus on are what differentiates us from other messaging applications. I usually talk about 3 points. So the first one being that we use onion routing instead of just connecting to users to a centralized server to send and receive messages. We don't require a phone number to sign up for Session. And then we also use a decentralized network as well of servers to store and route Session messages. So if you compared it to Signal or Telegram or something like that, those are kind of the 3 differences. Like Telegram or Signal would have a centralized server that all of your messages go to, and you talk to that centralized server with your raw IP address if you're just using the application as normal. And then those applications also require a phone number to sign up, Telegram and Signal. Signal has been putting in more username type features recently, but you still need a phone number to sign up, and Session doesn't require that, which provides a higher level of anonymity for the users of Session. So that's how I kind of distinguish it from the other messaging applications in the landscape.
Nice. And then why did you guys start Session in the first place? It sounds like you have some features that separate you from the other messengers, but were those absences in other messengers enough a reason to start Session, or was there another inspiration behind the project?
Yeah, so I mean, it's an interesting story because the whole project started back in 2018. And during that time, we were looking at the landscape of messaging applications that were available, and we didn't really see something that was combining different kind of decentralized and privacy-preserving aspects from different messaging applications. So you saw networks like Tor, which were these decentralized networks where you could get a high level of anonymity when you use them. And then you saw other kind of blockchain networks where you could incentivize a set of nodes that were running. So when we looked at the landscape, we thought, okay, how can we combine the interesting aspects of Tor being a decentralized network, the incentivization layers from blockchain, and build something which is different from other messaging applications out there. I mean, from a vision perspective, we were always very privacy driven, and we wanted to build tools that people would actually use in the real world. So we kind of took parts from different networks and combined those into Session. So Session is kind of an amalgamation of some ideas from Tor, some ideas from the blockchain network, some ideas from other messaging applications, peer-to-peer messaging applications like BitMessage and Tox, and then kind of merge those together into a really user-friendly product, which shares some of those properties from everywhere, ultimately with the goal to provide the most privacy to users and provide it in a user-friendly way as well.
Very cool. And then we can definitely talk about the tech soon. I want to touch more on the decentralized nature, the onion routing. But before we get into the technology itself, who is your team, and has it expanded over the years? Has it been the same? I feel like people don't talk too much about the team behind the projects they use.
Yeah, so as I said, we started in 2018, and there was 4 original founders at that point, all Australian guys who met up in the blockchain center at that point in time, because we were all kind of interested in new technology and decentralized technology. That team has grown quite a bit in the interim period. So we have team members all around the world. And we now have a Swiss arm as well. That's the steward of the project. So it's the team has grown significantly. I would say probably there's 20 to 25 people working on Session, and like all of the aspects of Session. There's developers, there's marketing people, there's operations people, all around the world. And I think, that's been a testament to like the tech that we're building is very cool, I think, and people want to get involved in products that people actually use as well.
Nice. With all that said and getting to know you guys, let's dive a little bit more into the tech here. So I have quite a bit of questions, and I feel like end-to-end encrypted messengers are hard because there's a lot that goes on into them behind the scenes. And so there's a lot of different topics to dive into. So I'm going to do my best to kind of navigate this and structure it in a way where we can kind of follow along. But why don't I start with just, you guys are open source. What's your general security approach? What's your typical user, and what are the typical threats that you see Session acknowledging?
I think it's difficult to describe like the threat model succinctly, and there's a lot of different types of users that use Session, so it's difficult to build something that will work for all of them. I mean, I think our North Star though is that when people download Session and use it, they should be out of the box provided an extremely high level of privacy. So that means we're doing onion routing by default. You don't need to use a VPN or like connect it to Tor or anything. When you download Session and you start sending messages, they're onion routed from the get-go. So that solves, for example, one issue where, with IP addresses, where if someone is talking to another person or talking to a centralized server, that centralized server would have the ability to see the user's IP address. And then also, if someone else is receiving a message, they're going to be able to know the IP address that is receiving that message as well. So that's something that we really wanted to focus on, and that's why we use onion routing like out of the box when you download Session. Another thing that we thought was really important was to not link a user's Session account to any real-world identifier, because that's a massive issue for a lot of users who either don't have a phone number, they may live in countries where they don't have access to it, or when you sign up for a phone number in a lot of countries, you have to give like an identity card or a passport or something like that. I know that that's the case in Australia at least. So we developed a system where you just generate a public-private key pair, and then that key pair becomes your identity on the network, and that is not linked to any other real-world identifier. So that was really important for us. And then I think if you really boil it down to like the most important thing that we're trying to build for is that the developers or the teams that work on Session or the stewards of Session don't have access to users' data and don't run the infrastructure of the network. And that's where the decentralized aspect comes into it. So if you think about services like Telegram or Signal or WhatsApp, they all have centralized servers which they run and that have access either to users' metadata or users' unencrypted messages. In the case of Telegram, most of the chats on Telegram are unencrypted. So that was really important for us that, as the developers of Session or as the team behind Session, that we wouldn't be able to access users' data, even if someone came to us and said, like, you're violating some law in some despotic country, give us all of the users' data, that we wouldn't just be able to say to them, oh no, we don't want to give that to you. Like, we have access to it, but we don't want to give it to you. We wanted to be in the position where we didn't even have access to that data and we couldn't get access to that data. So with the decentralized network of 2,100 nodes that's running all around the world, that's community operated, and that's the part that stores and routes users' messages, and we don't run that. So that creates a very strong protection for users and also a strong protection for us as well.
Very nice. And then starting, I guess, with the registration, there's no username, there's no phone number. So what is the identifier for a user? You said it's a public-private key pairing, but then what does it look like for a user once they're done registering?
Yeah, so when a user registers or when they sign up for a Session account, basically the device generates that public-private key pair and stores it locally. And then you get what is called, or what was previously called, a Session ID. We're now calling it an account ID. It's just a little bit easier for users to understand the account ID language. And then when you add another user, you either need you need their account ID to add them. So you can either share that via a QR code, or you can send your account ID to another user via email or whatever service you want to use, like to get your account ID to them, you can send it to them. We've also been working on a feature called ONS, which is, if people are familiar with the cryptocurrency world, it's similar to ENS, where you can kind of map a human readable name to that public key. And that occurs like as an on-chain transaction. We're kind of overhauling that at the moment to make it even easier for users to register those names. So then in that case, they would be able to add a user just knowing their username. So my username, for example, using that service is Kee Jeff. So you can add me on session using that.
Nice. And then is there a reason that you opted for that approach to usernames instead of something more traditional? Is that done because of the decentralized nature of session? So there's no way to have a central server handle centralized usernames? Is that why you guys opted for that?
Yeah. So like as soon as you have a username in the system, you essentially need to have a mapping between that username and the user's public key. And where that is stored is very important. So, if that's stored in a centralized server, it means every time you look up someone's username, you're asking that centralized server, okay, what is that, the username that I'm looking up, what is that public key that it maps to? And that creates additional metadata in the system and also presents a risk for like man-in-the-middle attacks. So, if you look up the name Kee Jeff and we had a centralized resolver for that, essentially the centralized resolver could say, oh, like I see that, Kee Jeff is this public key. I'm going to swap it out to a different public key without telling you. And then you're going to be messaging that user without really understanding that you're not messaging the user that you intended to message. And Signal has, tried to get around this with the safety number concept, and that's what Signal protocol does. But users don't often check their safety numbers, and they can change. And it's not something that's kind of familiar from a user experience perspective. Most people just expect that, okay, I'll look up this user, I'll start messaging them. They're not going to check that in the back or in the background. So when we built like Session, we wanted the primary kind of discovery method to be someone's session ID. And you can't then take that session ID and there's no lookup which happens essentially. Like you look up the user's swarm to send a message to them, but you can't, there's no man in the middle that can replace that session ID and like kind of initiate a man in the middle attack. So we don't have this problem is typically called the tofu or the trust on first use problem. And Session doesn't have that problem because of the fact that we use public keys as the primary identifier on the network.
Yeah, so for pretty much any contact that I'm talking to long-term on Signal, for example, I am maybe one of those few people that does do the key verification. We do a phone, we don't do it super official. Ideally you do it in person and you scan the QR code, but we just do a phone call on Signal and I just see it's them. I just say, hey, are you okay? Are you who you are? And then we just read off the numbers. Is that unnecessary on Session, or do you still have a similar feature?
It's unnecessary on Session because you are directly communicating and encrypting your messages for that public key if you added someone via their session ID. So there is really no way to intercept and man-in-the-middle attack that. If you scan someone's account ID or they've given you their account ID and it's coming from the right person, I mean, there's still the case, like if you send your account ID via email, then maybe your email provider could like switch out the account ID. But we don't have the same issue that other messaging applications have where that mapping on the centralized server can be swapped out. The worst that could happen for us is we do a lookup for the swarm that you're sending a message to. But even if, and that's done during like with the decentralized network. So when I get your session ID, I'll look up your swarm, which is basically the location where I send messages to you and you can retrieve them and they're stored for 14 days. If the network lies to you and gives you the wrong swarm, it just means that you're not going to receive messages from me. It doesn't mean that they can decrypt your messages. It just means that when I send you messages and they're encrypted, they're going to be in the wrong swarm, but there's not going to be the same ability to decrypt because there isn't the same ability to swap out that key.
Super cool. And then even in your, it sounds like you kind of natively deal with the issue and kind of your almost side channel attack of like an email provider changing the session ID is an issue that would apply to any other messenger as well. If you were to exchange, I guess, like the key for the conversation. So it's really cool. And that is not something that I guess it formally clicked in my head that I wouldn't have to do this whole thing that I normally have to do when I'm talking to people.
Yeah.
To kind of tackle some of the other selling points here, you mentioned it's onion routed. Has that always been the case? For some reason, memory tells me you guys didn't used to be onion routed, now you are. So what was the reason for that change, and how has that change been for you?
Yeah, so when we initially launched Session in, I think it was around 2020, we launched the Session product to people, and it was kind of in an early stage at that point. We used something called proxy routing, which was basically we would choose a random node in the network of that 2100 nodes, and then we would bounce your connection through that node before it got to the swarm that you were depositing your message in. So that was kind of just like one hop, and that wasn't super strong. That wasn't super strong, but that's what we launched with. And for I think the first year or the first 8 months that we were launched, we used that proxy routing system. But after that point, we upgraded to like a full onion request system. So that's 3 hops, and everything is, it has 3 layers of encryption, which successively get unwrapped as you send your message. So that's been running for would be like 3 or 4 years now, and that was important for us as well because like proxy routing was kind of an interim solution, and we wanted to develop something that was way more private and achieve the same levels of privacy of something like Tor.
So you're saying it's like Tor. Is it going through the formal Tor network, or have you designed a similar network to the Tor network?
So it's not using Tor directly. A lot of people I think that onion routing is like the name for Tor, but actually like onion routing is just a concept that Tor has employed, and it was the first one to do onion routing on a decentralized network. We've taken that concept of onion routing and implemented our own onion routing system, which we call onion requests. Onion requests are a pretty simple system. They don't use the Tor network. They use our network of 2100 nodes that is community operated. So when you send a message on session or you receive a message on session, you're using 3 random hops from that network of 2100 nodes, and you're onion routing through those nodes. So it's the same concept of onion routing. It's just using a different network and a different implementation, but the same privacy properties.
Got it. Is there a reason why you aren't just Tor routed?
Yeah, I mean, look, the main thing is like we have a network of 2100 nodes, and those nodes have like they're measured in terms of their performance. They have kind of a self-policing system where they test each other periodically, which means that the level of performance of session nodes is generally higher than that of Tor nodes, because Tor doesn't have the same level of like when you run a session node, basically like stake an amount of cryptocurrency around that, and then you can be removed from the network with a financial punishment because of that system. So it allows us to have a lot better civil attack resistance in terms of, to join the network, you actually need a financial stake. So you can't just run 1 million nodes in the network. You actually need to put some financial backing behind that. And also it means we can more aggressively require certain performance requirements. So that could be something like, you need a certain amount of bandwidth, you need a certain amount of storage to run one of these nodes. And it just generally leads to a more performant and reliable system than what Tor would be if we implemented that.
Got it. And then regarding the decentralization, a couple concerns that I guess myself and I see a lot of people share regarding decentralization. The first one is something can be decentralized in theory, but not really decentralized in practice. So how decentralized is the network in practice?
Very, very decentralized in practice. So there's probably 200 plus different operators all around the world. And these operators are anonymous. So it's, we don't do KYC on our operators, so we can't tell you, exactly who they are. But just like anecdotally, like we have communities that are set up with all of the different operators in them, and you can see that they're like clearly different people who are contributing to the network. So there is there is some people running more than one node in the network, but there's hundreds of different operators, enough to the point where you're getting both geographic diversity in the like set of routers and storage servers that are actually handling your messages, and also like getting operator like diversity as well. So it's not just like one person that's running the entire network. It's hundreds of people from all different jurisdictions, and their nodes are also in different jurisdictions as well.
Nice. Do you guys run any of your own nodes?
So the foundation runs 10% of the network. I mean, there's like different people in the network. Like I run some nodes, like different people, in the team would run nodes as well. But that's just because, we like Session, and we're obviously, want to be involved in the protocol that we're building. But I would say like probably between the foundation and the team, there's maybe like 15% of the node network is run by us, and then it's all different operators from all around the world.
Very cool. And then another concern regarding decentralization, I see this talked about a lot with Tor, is the percentage of nodes that could be run by things like governments. So in a situation with Session, do you, I guess, have a way to prevent that, or is it even really a concern? I assume the protocol itself is designed in a way where even if somebody runs a malicious node, there's not much they can do. And I think you kind of hinted at that earlier with the swarms.
Yeah, so we essentially like try to assume that the node network isn't honest, even though like every indication is that the node network as a whole is honest. But because of some of the things that we do, like for example, not requiring a phone number, onion routing messages, and end-to-end encryption, it means that like what the servers actually see in the network is very little like metadata. They're basically just transmitting encrypted blobs from one node to another. So there's very little you can see when you run a session node in the network. And I think like there is still concern, like if you were to have, say, one party running 30 or 40% of the network, then your onion routing guarantees start to break down, because it's the same thing with Tor. Like if you're at the first node and you're the last node in the network, or in the path that you've created, then you can essentially like correlate someone's incoming IP address with the destination that they're talking to. But another thing on that, which is slightly different to Tor, is you don't speak in session, you don't speak directly to the user that you're wanting to send a message to. You actually speak to the swarm that you're depositing your message to. So, and then the other user also has their own independent path, which they're talking to their swarm with. So it's, if you kind of think about the process of like sending and receiving a message, there's one full path to the swarm, and then there's another full path to the receiver to the swarm. So you end up with like 6 or so nodes involved in the full sending to receiving path, and those paths are independent from each other. So to compromise that entire path route would be like quite difficult. You would need a lot of nodes in the network to be able to do that. In terms of like preventing governments or preventing attackers from running nodes, that's where it kind of comes back to the idea of like session being more civil resistant than other networks. So in Tor, for example, if the government wants to run 2,000 nodes, they can just rent the server power to do that. They spin up the nodes, and then they become part of the Tor network, and they start routing traffic. And that's a major concern for a lot of people. In session, to be able to do the same thing, you would need a significant financial stake as well. So you'd need to buy a bunch of tokens, stake those to the nodes. And then if you're seen as performing poorly in the network, or it's discovered that you're a government actor and you're kind of impacting the privacy of the network has the ability to slash those nodes and remove that financial stake as well. So it creates a barrier to entry. It's not perfect. Like governments have a lot of money, right? So they can spend a lot of money, getting the financial stake to do this. But it means that there's a high risk for a large amount of sunken cost. And as those tokens start to be bought up in the network, the price to add more nodes becomes higher and higher as the price increases. So it's not a perfect solution, but it does create additional barriers to malicious parties running a large portion of the node network.
Got it. And then you mentioned metadata very briefly. Do you mind giving a quick explanation of how your metadata compares to other popular tools?
Yeah, so like I would say with most messaging applications that are out there that either use a phone number for sign up or use a centralized server, there's going to be metadata from the users that are using that application in the default way. So if you think about Signal, for example, when most users use Signal, they're sending a message to Signal's servers, which is going to mean that their IP address is interacting directly with the Signal server. Now, Signal at that point has the ability, they say that they don't put any logs in, and that I believe them that they don't do that. But we should kind of be operating on the principle of not needing the service provider to be trustworthy. So if Signal were compromised, for example, you could see the direct link between someone's IP address and the message that they sent to that server. And it's the same thing on the recipient side as well. So when someone goes to fetch a message from Signal's server, they're generally going to be interacting directly with their IP address to that Signal server and pulling the message down. And then you can do stuff like timing analysis. For example, okay, one user sent a message with this IP address. We saw that message was retrieved by this IP address. And then it's like, okay, those two IP addresses, where are they located? Like, can we talk to the ISP that's involved in that to get the user's identity when they're talking on the network? And similar things go for the use of phone numbers as well. So, because your phone number is tied to your public key on the network through a server, then there can be resolution between that phone number and the message that you're sending or the person who's receiving that message. So from that perspective, that's where most of the metadata lies. I mean, there's more, like if you look at something like Telegram, they don't just have metadata, they also have the contents of messages a lot of the time if you're not using secret chats, which most people don't use. So they would have then your IP address, your phone number, the contents of the message in most cases there as well. So from our perspective, like Session completely removes that linkage by using onion routing and then not requiring a phone number to sign up to the service.
Yeah, and so besides more of the hypotheticals, so what we've seen in court cases now is in the context of Signal, when they had to hand over what they could in legal cases. I think it came down to the last time a user was online and when they registered for their account. If something happened like that with Session, maybe it already has, so correct me if I'm wrong, what would that look like for Session?
Well, we really can't hand over anything because we don't run the nodes in the network. So if someone comes to us with someone's session ID, for example, we can't tell them when the account was registered because there is no central registration process. Like when you generate a session ID, you just generate a public key on your device and you can start messaging other people using that. We can't really tell when the last time a user sent a message because, again, we don't run the infrastructure in the network, so we don't have access to those servers to be able to tell when a user sent that message. So from our perspective, it's usually the case that we run some official communities in the network. So if the user had joined those official communities, like the session updates channel or the official session community that we have for people to just have a chat, we could block them from those communities that we operate. But there isn't really much more that we can give. And that's we publish transparency reports as well via the OPTF, which was the previous steward of the project. And you can see in those transparency reports that there hasn't been any user data which has been given up just because we don't have access to that. And that I expect will be the same thing with the Session Foundation in Switzerland moving forward as well.
Nice. And yeah, I definitely want to touch on the foundation and that in the future here in this interview. But a couple more technical questions. Like I said earlier, there's a lot that goes into end-to-end encrypted messengers, so still a few more things. So the first thing is blockchain. I think that's a very polarizing word as well as cryptocurrency. So why, I guess first, where If I'm a session user and I open the session app for the first time, where, when I'm communicating with someone else on session, is blockchain involved in any way?
So, like as a session user, you're not really going to see any of the blockchain stuff that's happening, which was a very intentional choice because we understand that, like the reputation of the blockchain industry and the cryptocurrency industry obviously isn't the best. A lot of people think, like when they think of crypto or blockchain, they think like scams and meme coins and like all of these like kind of garbage projects that are floating around. So we wanted to intentionally, not require people to like have a token or like be involved in the blockchain ecosystem to use Session. That was always what we wanted to do, on the layout. The part where Session does use blockchain is in that node network. So that network of 2,100 decentralized nodes, it's running all around the world. Those nodes are receiving an incentive via a cryptocurrency to continue to operate. So essentially, like there's a financial stake that they have to put in, but then there's also a reward for what they're doing, and they get paid that out. On every 24 hours, they get a little reward for routing and storing session users' messages. So it's the incentive layer for the node network where the blockchain comes in. But yeah, as I said, most users don't really need to worry about that. That's not what we've been trying to push into people's hands.
And then I guess one other question regarding blockchain, because I think the general definition that people think of is it's a permanent ledger.
Yeah.
So you mentioned earlier that node operators, they see just encrypted data. Is the encrypted data itself being stored on some kind of blockchain? Because then what would be your, I guess, security protocols for thinking 100 years down the road? Can all those messages be unencrypted later, I guess would be the question.
Yeah, so no, we don't store any messages on chain, which was really important for us. Like not only just from a security perspective, but also like from a scalability perspective. So I think Session deals with something like 100 million messages every 14 days. So to have every one of those messages be a transaction on blockchain that's stored forever, you basically like blow up the size of the blockchain massively as you start to store, more and more messages. So the way that it actually works is we have this construct called swarms, and swarms are a collection of 7 of the 2,100 node network. And essentially, when you send a message to someone, you send a message to their swarm, and that message is then replicated 7 times. So if any of the nodes go offline on the network, you still have that copy stored, and then that copy is stored for 14 days and then is deleted from the storage servers themselves. So none of that happens on chain. It's just that each of the nodes in the network has a small amount of storage, and they store the message there. And then when it gets to 14 days, that message is removed. You can also push that storage time down with disappearing messages as well. So if you're using disappearing messages, you can set your time to say 1 day, and then the message will be deleted from those storage servers after 1 day. It's important that we do have storage in the network though for usability, because a lot of early peer-to-peer style messaging applications, you wouldn't be able to send a message to someone if they were offline, which is very important for usability. If someone turns off their phone and then when they come back, the message isn't there, that's a really poor user experience. So temporarily storing that message allows a user to have their phone offline, and when they turn it back on, they can actually fetch it from that network from their swarm.
Nice. And the reason for the swarm, was it originally for stability and reliability, or was it to add anonymity, so something more like ring signatures almost?
The reason for the swarm is kind of almost purely for reliability. So nodes on the net, like there's this network of 2,100 nodes. Those nodes can come offline or go online, at any point. You can add new nodes to the network. You can also remove nodes from the network as well. So we didn't want the situation where, say, if you were just storing the message on a single node, if that node went offline, then you wouldn't be able to retrieve that message anymore. Whereas if you replicate, and what we're doing is, 7 replications for each message, that basically allows like a large portion of the node network to go offline, and for you to still be able to retrieve your message and not run into any kind of user experience issues there.
Nice. And was 7 just a good number?
Yeah, we really I mean, there's a sliding scale here. So you can imagine like one node would be, because your sliding scale has kind of two axes. One is we want to limit the amount of storage that the network is using. So if you replicated every message across every node for 14 days, then the storage requirements for every node would be quite high, right? So that would be the maximum replication, but you would be able to tolerate basically like a failure of the entire network because your message is still going to be stored on one of those nodes. And then on the other end of that scale, you have if you just stored your message in a single node, which would be like if that single node goes offline, you lose your message, but then the storage requirements would be way less. So we were essentially just trying to balance between those two. 7 gives you like a high number of replications where a bunch of nodes can go offline and you can still receive your message, but also doesn't burden the network so much in storing every single message for every single user on every node. So it's kind of a balancing point. I honestly think 7 is probably a bit high. You may, bump it down to like 4 or something like that because, still you get this like property of lots of nodes can go offline. You still are able to receive your message and it reduces storage as well. But that's something that, can be tweaked in the protocol.
Very nice. And then account recovery for people who might not, implement best practices with how they use technology. If they don't have, I guess you're talking about you just generate a private public key pair. So what is the login to a session account?
So when you generate a session account, you generate that public-private key pair. The private key is represented in session as a mnemonic seed phrase. So basically like 12 random words from a word list. If people are familiar with Bitcoin wallets or cryptocurrency wallets, it's basically the exact same thing. So if you write down those 12 words, you can always recover your account, and you can also link accounts together with that 12-word seed. So that's essentially the account recovery process. You can completely delete your session account, but as long as you keep that 12-word seed, you can come back and recover your account later.
But if you lose that seed, you're done?
Yes, if you lose that seed, you're done. And that probably has been a problem for us previously because most messaging applications would use a phone number to sign up for the messaging application. And as long as you keep access to that phone number, then you can always get access to your account again. That creates problems in itself because the phone number system wasn't designed with the thought that it was going to be securing a lot of people's messages or account data. Like these days, like you sign up for an account for Google or any of these services, typically you're going to enter a phone number. So there's a lot of value in your phone number right now, and now we're starting to see like SIM swapping attacks coming through where people basically gain access to someone's phone number and then are able to take over their accounts just because they have a user's phone number. So for us, it was important to move away from that. But I think in the future, we are going to make the concept of having that seed way easier to back up. We're looking at systems like passkeys, for example, which allow you to have a private key which is stored, on the device's secure enclave and then can be shared with other devices through a cloud system. Like, Apple has their iCloud and Google has their own system for that. That would be something that users would have to choose if they wanted to. They could still use the 12-word seed if they wanted to, but for most users, it's probably going to be easier just to store a passkey in the device and then be able to, even if their device turns off and they didn't back it up, it should still be backed up in the cloud for them by the device provider. So that might be an option that we look at in the future.
Nice. That's a really cool concept. And is there a way to back up messages in the event that you need to? Can you back up and restore to a different session account? I don't know what the possibilities are like for account recovery in that sense.
Yeah, so we don't have like database export working well right now. Like so we have an iOS app, we have an Android app, we have a desktop application, and they all use slightly different database like schemas. So it's difficult to build a system where you take one database from your iPhone, which has all of your messages, and then take that to desktop and then restore that there. That is something I think that we will develop more in the future, so you are able to have that account portability. But right now, the storage server network, that network of 2,100 nodes, your swarm, will store messages for 14 days. And there's also something called a config message as well, which contains like stuff. It's an encrypted message which contains like the contacts that you've spoken to, the groups that you're in, basic information like that. That's stored for 30 days. So basically, like if I was to lose my phone, but I still have my seed, I could then recover like all of the messages that have happened in the last 14 days, and then also like a empty like state conversations like with the groups that I've had and also the contacts that I've had. So as long as you're online, every 30 days, that config message gets refreshed. And if you lose your device, as long as you restore it within that time, you'll get some of the messages back, and then also like the conversations that you've previously been in would also be restored there too.
Awesome, super cool, really thorough. And then definitely, I think the infamous question that everybody asks, because I guess it's seen as like the main con to session, is PFS, perfect forward secrecy. And I know it's something you guys get a lot, so I'll go ahead and just let you, I guess, explain what it is and why you guys opted to not go with it.
Yeah, so perfect forward secrecy essentially provides some security in specific scenarios. So perfect forward secrecy is typically talking about when a long-term key in the system is compromised, and the attacker also has been able to scrape messages from the network or the servers that store messages as well. So in the case of session, if you just think about perfect forward secrecy from a first principles perspective, like if your messenger is built securely, the only way you should be able to compromise someone's long-term key is by getting access to their device, because that's where the long-term key is stored. It's stored on the device only. It's not synced to the server or anything like that. So from that perspective, if you have access to someone's local device anyway, the level of attacks that you could perform from that perspective are much higher than, or much more damaging than the protection perfect forward secrecy provides. In terms of perfect forward secrecy is generally trying to provide, if they scraped all of those messages from the server historically, and then they got your long-term key, that they wouldn't be able to then decrypt those messages that they scraped from the network. But if they have access to your local device, then, and they have access to grab your key from your device as well, then that necessarily means that they're going to have access to like go into your account and just see the messages there anyway. And if you're not using something like disappearing messages or deleting all of your messages, if they open your Signal account, for example, they're just going to see all of the messages plain text in the account itself. They have access to your local device. They can also just install like screen recording software or like a keylogger, which would like continuously send new keys that are being generated via perfect forward secrecy to their backend, so they can continue to persist their access to your device. So, I mean, essentially, like my perspective on perfect forward secrecy is like it's quite a like technical kind of cryptography tool that you can use, but I don't think it's actually applicable to most users in most cases. It provides some protection in edge cases where a attacker has both network access to scrape messages and then also local device access, but then they don't want to use that local device access to persist or scrape messages directly from your database. So I think it's quite edge casey. It also, like, the reason that it wasn't implemented is it creates a lot of issues specifically with decentralized protocols where you don't have a single central server that can store messages forever because you're constantly rotating keys. And in the decentralized context where you don't have a single source of truth, that rotation of keys can end up where, you know, if you rotate your keys and the other user doesn't receive the new keys that they're using for the encryption, then you can end up encrypting messages for a key that the other user doesn't have, in which case they can't see your messages. So it creates a lot of headaches from a decentralized perspective to employ that protection. So I would say, like, Yeah, I think it's more of a cryptographic protection than an actual real world applicable connection. We have some blogs on this. I probably didn't explain that super well, but and you can read through those. I wouldn't say like it may be something that we implement in the future as well. Like I'm not putting that off the table. It's just been really hard from a decentralized perspective because perfect forward secrecy typically relies on the sharing of pre-key bundles and stuff like that, which is usually done through a centralized server. And when you don't have that, it becomes much harder.
Yeah. Do you know of any decentralized project that has been able to pull off PFS? Or if you guys were to do it, would that be kind of a first?
I mean, we had perfect forward secrecy initially, like in the first maybe 6 to 12 months of running, I think. And it was very difficult to get working properly. And we did have a lot of those situations that I was talking about before where, you would rotate the keys because they're constantly rotating. And then if the user was offline for 14 days, for example, they wouldn't have gotten those new keys. We also had it created like a problem with message requests being much larger than they originally were because you needed to include the pre-key bundles in those message requests as well. So I'm not aware of any project that is decentralized that is using perfect forward secrecy. I mean, probably the closest thing would be like maybe SimpleX. I think they are using the Signal protocol, but I wouldn't call SimpleX decentralized. It's more kind of self-hosted or federated. There's a centralized server which would store that information. Typically, that's going to be by default, it's going to be the SimpleX servers that people have set up, or that SimpleX Limited or whatever has set up, and then you're going to be using those unless you're running your own relay. And then in that case, it would be more towards the decentralized aspect, but you're still kind of talking to one centralized server, so it becomes a lot easier of a problem to solve.
Got it. And then, a couple more technical things, and then that's it. I promise. And then we'll get more into the fun stuff to everybody listening. So, were you guys not originally forked from Signal, or was that just the desktop client? Do you mind explaining why that was done and why you shifted away from that?
Yeah, so all of the session clients are Signal forks, and that's still the case till today. So the reason we did that was because we thought Signal was the best base to build from. When we started the project and we started building Session in 2019, we saw Signal as like obviously being the most private, having the most metadata protection. So we wanted to build from that base. I think like now, even though we're still originally a fork of Signal, the code bases have kind of diverged to such a degree that we still have some of the Signal code in the application, but most of it is custom code that we've written ourselves at this point. But we still share that lineage and history with Signal, and there are still functions and database and a lot of things that we still do call from Signal.
Nice. And then on that topic, last time I tried Session, it's been a while since I've tried it, and it was, I want to say, 2020, 2021. It was before there was a landscape iPad app. So it's been a long time, and I just remember really liking the tech, but it being usability-wise not what I was really familiar with. So how has usability come along the last few years, and what are kind of the major revamps you've done there, and are there still things that you want to improve on from here?
Yeah, I would say like there's been a massive usability increase, and I think as usability has gotten better, like we've seen the user numbers go up as well. So I think Session announced recently that it just surpassed 1 million monthly active users using Session. So like it has increased massively since 2020. I think a lot of the solutions that we've been putting in recently have been focused on usability as well. So just give you like one example of something that we did recently. We like completely overhauled the onboarding experience. So when you create a session app, like when you create a session account for the first time, previously we were kind of like front loading a lot of the technical complexity into that onboarding process. So we would try to make the user back up their seed. We would try to explain the concept of an account ID to a user because that's kind of unfamiliar to them. What we've done more recently is remove a lot of that complexity from the onboarding and just have it so that the user enters a username, like a display name. It's not really a username that you can look up on the network, but a display name that displays to other people. And then they choose their notification mode, whether they want to use like Google, Apple push notifications or just not use them at all. And then they're into they have an account. So then they can start sending other people messages. We don't try to explain the account ID. We don't try to get users to back up their recovery phrase, recovery password. The main reason for that is like the recovery password doesn't actually mean anything until you actually start to onboard in session, until you actually start to have conversations on session. Then it becomes important to back it up. So at a later point, kind of past the onboarding process, then we tell people to back up their recovery phrase. So I think that's just one example. There's been a lot of things like that which have gone throughout the entire session process. Another one is like making sure that when messages are read on one device and you have devices linked together, or even the concept of linking devices together, like we've improved massively. But like when you read a message on one device, that it's read on another device, so your read status is like syncing between devices, messages are syncing between devices. That's huge. I know that that's something that not a lot of messages do well. I think that has had a big impact as well. One thing we're looking at right now is like getting the calls feature to work better because it's been in beta for a while, and we want to make that a first-class experience. So right before I jumped on a call with you, I was testing like a new Android build, which was like fixing up some of the call functionality. So I'd say like usability has increased a bunch since we initially started. I'll have to check whether we have the iPad landscape view though.
Do now. I believe so. That was something I remember people acknowledging was fixed. Because I remember when I tried it, it was really funky because I took a photo of myself, but the app is only portrait mode, so it was like a 45-degree turned version or 90-degree version of my face, pretty much turned on its side as the profile photo. Which was just funny. And I do remember that someone said, "Oh, this has been fixed now." And I go, "Oh, that's really nice." And it doesn't matter because I don't have an iPad anymore. But I know a lot of iPad users, I think, will probably know they're normally treated as second-class citizens, which I think we can partly blame Apple for in a lot of ways as well. Because I think Apple in many ways also treats their iPad users as second-class citizens.
Yeah.
But
yeah, it's always tricky like when you're dealing with kind of platforms that people don't use as much as well. So like the majority of our users would be on Android and iOS. So we try to like focus development resources or like our tasks towards those users. And then it does become the case that like some users like don't get features as fast as others.
Yeah. But no, I'm sure from everything I've heard, people have overall been praising the usability, especially since I used it, which was a long time ago. So it's just really nice to see that being prioritized because I know that's something that matters for especially people who aren't going to be listening to this podcast, frankly, right? Like it's the people that they will be onboarding, friends, family, etc. You mentioned linked devices, and do you have a similar linking system as Signal where you kind of have to have a phone to set it up? Does it have to be the root device, so to speak, and then every other device is kind of a branch from that? So what is it a similar system on Session, or do you have something different?
No, it's actually like kind of a completely different system. So there's no concept of a root device. Like the concept of your account is basically just that recovery password that we have, that 12 words. So you can take that to desktop, you can take that to Android, and if you already have an active device, say on iOS, and you want to have your desktop account linked, you would just take that seed phrase, you put it into desktop, and then now you have like a desktop client which is synced to your iOS device. And when people send you messages, you get that both on your desktop device and iOS device because they're essentially both talking to the same swarm. They're both getting the same information received from that swarm, basically.
Nice. And then you mentioned briefly the option to change notifications, which is a really cool feature, by the way. Do you have any kind of, on the Android side of things, because I don't think this is possible on iOS, but on Android, do you have like a custom built notification system that you can use, or why am I blanking on the open source push notification system on Android?
Unified push, there was
Yes, unified push. Thank you. Yeah.
So essentially, like I would say, so like when a user signs up to session, and this is the same for Android and iOS, not for desktop because you can't really get push notifications on desktop anyway. So we just use a system of like when the app is open, you poll your swarm, check for messages when they come through. On Android and iOS, we offer the user the option of what we call fast mode or slow mode. So fast mode is essentially you're going to use either the Apple APNS servers or the Google FCM servers for delivery of push notifications. If you use what is called slow mode, essentially we don't have a system that's advanced as unified push yet. Basically, we just try to wake up the application every X period of time and poll your swarm for new messages, and then we'll notify you of those new messages locally. So that's the same system that Session uses when the app is open. We'll use that same system. I will say, like, the issue with especially iOS is that running background tasks on iOS is extremely limited because iOS tries to optimize very heavily for minimizing battery usage. And if you're trying to minimize battery usage, the OS will basically only allow you to like start up the application and poll like very irregularly. So it may be like every 8 hours. Like we actually don't know. We just ask the OS like to start the application up and poll, but we actually don't know as application developers when it's going to be allowed to start up. And then you're only allowed to poll within that period of time for 30 seconds, I think it is. So that's enough time to get all of the messages back from your swarm and deliver them. But obviously, like getting notifications every 8 hours is not the ideal experience. The approach that like unified push and kind of these open source systems use is like that they try to connect to their own like server to deliver push notifications. But I don't know. I'm not sure exactly what the state is now, but I think Apple is like very aggressive at like limiting background connections between you and another.
It's Android only.
Yeah. Okay. So yeah, if the other way to get around it on Android is basically you have this like persistent notification which displays in the taskbar, which allows your application to stay in a foreground mode to deliver notifications. That's not something that we've implemented yet, but that probably is a direction that we will look at in the future. And there's one more thing which is quite interesting for us as well. I talked a little bit about onion routing and onion requests before. The system that we have in Session right now, which is called onion requests. It's a pretty naive implementation of onion routing. It's a non-streaming protocol. You basically just send off a HTTP request, which is kind of wrapped in several layers of encryption, which get peeled off over time, and then your message comes back to you. We are working on a system called LokiNet, which is another onion routing tool that we've been building out in the underlying background. And that system works much more like a VPN. So if we were able to get LokiNet into the application and integrate into the native system's VPN modules, then we actually could run the VPN at all times in the background. And that would also give us a way to be able to poll your swarm in the background at all times as well. So
that's clever.
Yeah, from that perspective, if we're able to do that, then we may be able to get something working as well. Something that's also important for us with push notifications is that the slow mode system that we implement, or the alternate push notification system that we implement, also be onion routed, which unified push and services like that don't support onion routing of push notifications as well. So that's something that we need to work on there as well. So if we do something like slow mode, we also want it to be onion routed as well, which creates additional technical complexity. But yeah, there's a few ideas there, and we'll see where we go into the future.
The LokiNet idea of using the VPN essentially as a way to fetch notifications is very clever.
Yeah.
And very, very quick question. On the Android side of things, because on iOS, I'm sure it would be better given what you shared with iOS. And um, I I know one of the Cake Wallet devs uh, was complaining to me about trying to set up background sync for Cake Wallet for things like Monero and Litecoin MWeb and stuff like this. And they were telling me like the 3 ways that you can pretty much wake up an app in the background. And the way that Apple even describes it is we will periodically wake up the
Yeah.
app. It's something very broad and vague, and they just make it impossible
Yeah.
to know what that means. But on the Android side of things, um, what do you think would be better on battery for people listening to this? If they're using slow mode, which wakes up the app periodically, but keeps the app offline and not using the notification system, or just using Google's, which is probably running for most people all the time anyway.
Yeah, I mean, using Google's notifications is going to tend to be better on battery because it's only going to wake up the application when you actually receive a push notification instead of periodically. Like, I think we try on Android every 15 minutes to like get the application up and check for new messages. But say like if you haven't received any messages in the last 15 minutes, then it's basically just waking up the app, polling a server for no reason, which has some battery impact because you're using CPU cycles. Whereas if you use like Google servers, they're only going to tell you to wake up the application when you receive a new message.
I'm curious if the number of messages somebody receives in a day influences that number, because if you're receiving a message every 30 seconds for the entire day, then it might actually use more battery than just having to fetch the app every 15 minutes.
That's true. Yeah, that's true.
Yeah, I guess, yeah. So I guess something for people to think about if they want to see the best battery and something to play with for any testing for you battery nerds like sometimes myself. I have right now, like one of the phones I had is a 13 mini and the battery's starting to go to crap, which is pretty normal for the mini lineup. But I just love the mini form factor.
Yeah.
And so I don't know if that's going to change. I'm leaning a lot more heavily to just paying the $89 to swap out the battery and keep the same phone than to get a new one. But battery is something I think about.
Actually, there's like quite a few people in our office and that I've met in real life who are on I think the iPhone 13. They made like a mini model of the iPhone. It was last year, I think, that they've made it, and they've discontinued it now. But they're basically like,
yeah, that's mine.
Yeah, exactly. Like they're using that because they love the mini screen format, and I think they were very sad that Apple hasn't renewed that format and probably won't in the future. So when
that is me as well.
Yeah, when Apple stops giving device updates, they're probably going to be a sad day for them.
You're very sad. Yeah, I'm honestly very open to any small device that people are willing to make on the iOS, Android, any front. I don't really care what it runs at this point because I'm not somebody who likes big phones, and like you said, Apple just keeps making them bigger. So we're kind of done talking about tech, but I think it was necessary because there's just so much going on here, and like I kind of alluded to before we started the section, there's a lot that goes into messengers, and people probably don't normally think about how it links between their devices, how notifications are delivered, what's going on behind the scenes. So I really hope this gave a nice breakdown. Now I wanted to talk a little bit more about Session. One of the initial questions that a lot of people might ask, because it's a free application and you guys are open source, what's the business model? Because you mentioned you guys have a pretty large team.
Yeah. So like right now, Session doesn't generate any revenue and it's offered for free. You can download it and use it for free. The eventual like business model that the Session Foundation teams working on Session are working towards will be a pro model. So like essentially you think similar to Telegram, how Telegram has Telegram Premium, which is a subscription service for $4.99 a month. And that essentially offers a bunch of premium features. So it might be stuff like larger file uploads, more profile customizability, larger groups, different like badges that you can put on your profile and stuff like that. So it's mostly like cosmetic features and features for power users who are uploading larger files. So that's similar to what Session Pro would look like. It would be a subscription service that offers a bunch of premium features to the users who use the messenger. And the hope there is that there's this core user base of power users who maybe are around 2 or 3%, and you're able to monetize those users. those users pay back to the network. The network is rewarded for continuing to run that network of nodes, and then the system is sustainable in itself. And also, you can bring some money back to the developers to continue, or the teams that are working on Session to continue to develop the protocol while still maintaining a free tier that 97% of users are just going to use normally, and still be provided the same level of privacy, still be provided the same level of usability. It's just like you're kind of taking those users who use Session a lot and offering them additional features.
So for the last 5+ years, then what has been the way you guys have been going about it?
So we have the token side, obviously, which is what I was talking about before. And we have been able to raise money for the token to develop out that system. And then eventually, what I'm talking about here with Session Pro, that will flow back into essentially the token, the ecosystem, to continue moving things forward there. So mostly thus far, it's been venture capital money coming in and supporting the team from the token perspective.
Nice. And then this was a really interesting one to read about when it happened, because we cover news over on the surveillance support side of things. Australia, one of your team members got a knock at the door, and it was law enforcement. And do you want to talk about what happened there and what, I guess, why it led to the foundation?
Yeah, so I think essentially Australia has been going down a path of more and more kind of draconian legislation, which blocks people being able to use privacy tools, but also, recently Australia announced that they're going to ban social media for under 16s, which can only be implemented if everyone is required to kind of prove their age when they access a social media site. So I think Australia has been moving in this direction for quite some time. Session has inherent protections against, some of these overreaches from a legal perspective, because first, the app is open source. So if we were forced to put anything into the application, then it would be clear that that was happening from an open source perspective. But also in the fact that we don't run any of the servers in the network. So there's very limited access to data that the developers that work on Session or people in Australia have access to. So from that perspective, it's kind of a protecting factor. But I think the ultimate thing is the legislators in Australia, I don't think, have a full understanding of how decentralized technology works. They try to map their understanding of decentralized technology onto centralized models. So when one of our staff got a knock on the door, there was a lot of kind of questions around where are the centralized servers? How do we get access to users' data? How can you help us? Type of thing. And I don't think that they really kind of understood that Session is built differently from other messaging applications. It's not like Telegram, where the founder gets arrested in France and then potentially has to give up the encryption keys, and then you have all of the users' messages being compromised. It's not the same case, but I think they're applying that same kind of thinking. And yeah, it's concerning from our perspective, and that's kind of why the STF was set up, the Session Technology Foundation in Switzerland, and the stewardship and all of the releases are moving up to that organization so that we can have independence from Australia and not have the same level of kind of threat or misunderstanding as well from Australian regulators to regulate Session in the same way that a centralized messaging application would be regulated.
Yeah, the Telegram thing was really crazy to watch happen. And I think it was really weird to see a lot of the Telegram community act surprised about it, because I know on our ends, and most other people who ever touched on security when it came to end-to-end encrypted messengers, which I wouldn't really call Telegram that's being generous, they were always saying, well, they always could just hand over messages. So even if we assume they're not, which they did because there's evidence of them doing so, and I think Brazil and India even some years back now. But that could always change overnight. And so you never want a model where you just trust an individual or you trust a company. Ideally, you go as trustless as you possibly can. And it doesn't even have to be decentralized to move in a trustless way. As we talked about today, something like Signal is quite a bit more trustless than Telegram, and in Session seems like it's even more trustless than Signal. So just as a side note, that was a crazy story to hear about, and I think it's a really good reminder for people to watch the tools they use. But how does from a legal perspective, how does moving the foundation to a different country change things? Can Australia still go knock on one of your guys' door and give you guys trouble? Does having a foundation in Switzerland really change that root concern for you guys?
Yeah, so it's not just about having a foundation in Switzerland. We are moving like some of the development efforts to Switzerland as well. So, for example, I'm going to move to Switzerland in the next couple of months. So like in the new year, I'll be moving there. So we're actually going to start moving like a substantial portion of our base to Switzerland. The developers there will be some developers that still reside in Australia. Like obviously we have a big team, we've built it up here. So it's hard to get everyone, to move to Switzerland. But I think the right way to think about it is that essentially the Swiss company will have ownership over all of the code repositories, like the App Store listings, the website, like anything that is controlled in a centralized manner, because it has to be. Like you can't have a decentralized organization owning an Apple account, unfortunately. So there does need to be some sort of steward of the project. And then there'll be teams that work on Session. So there'll be a team of people that work in Australia from an open source perspective that develop open source code and contribute that to the GitHub repositories that we have. And then there'll be people in Switzerland who review that code and then merge that in and then create releases and put those out on the app stores and put the APKs out and stuff. So I think we're moving, I think the Session teams are moving towards a more decentralized model where there's going to be several Session teams located in different locations all around the world who work on Session and contribute open source code. But the centralized aspects, the ownership of Session code repositories and stuff will be in the hands of the STF. So if that explains it, it's kind of like the idea of
it does.
The Australian, if you think about the idea of like maybe Microsoft, for example, they develop software, they have, if they contract out some of the development services to a firm that's in, India, for example, then the Indian government probably wouldn't come after the Indian development company who's just working on code that they're contributing back to Microsoft in an open source way. They would probably want to come after Microsoft itself. So that's the kind of model that we're thinking about, that there's several teams that work on Session and that the ownership is up in the STF, but people in Australia and other countries are just kind of developing and contributing in an open source way.
Super cool. I think that explains it very well and definitely helps me understand things better. How have you guys, I guess, prioritized, because you mentioned the App Store, and it's a really good question. On iOS, unless you're in Europe, there's not much you can do right now, right? If Apple is pressured by any government like Australia to remove Session from the App Store, they're going to have to comply, and we already see this with VPNs in Russia and China, and Apple's more than willing to comply with governments, it seems like. On Android, you guys have more options. So I guess, is this something that you're thinking about? What kind of protections do you have in place for users where the app itself might be blocked where they are?
Yeah, so as you said, it's tricky for Apple specifically because they don't offer the same level of ability to sideload applications unless you're in Europe. And then that also comes with a whole bunch of different financial requirements. Like if you want to be listed in the App Store and then also an alternate App Store, you need to agree to these like crazy terms that they set out. So I think it's really hard to distribute the application in a secondary way. We do have an IPA that we publish for. IPA is essentially like iOS's version of APK, where you can kind of download the IPK and then install it on your device. But that only works either if you're in Europe and you can sideload applications, or if you have like a developer like license, or if your iPhone is jailbroken, which is not going to be the case for 99, or like a lot of people are in Europe, so there is some way there. But for 99% of users outside of those countries, they're not going to have a jailbroken device, and they're not going to have like a developer license to be able to install IPAs. So from that perspective, it's really tricky. I think like where you go from there on iOS is probably looking more at the web side of things. So how can we develop a web client which functions, very similarly or in the same way to Session on iOS, that people can just go to a website and can start using there. And I think that is the direction that we're kind of moving in slowly. It's a very heavy lift, to develop a web client when you're storing a lot of information locally. So, and web and local databases aren't perfect right now. It's much easier to develop a web client if you're just talking to a centralized server and then you just load everything in. That's why Telegram, like it's so easy for Telegram to do like Telegram web. But we are moving in that direction, and there's like exciting things that are happening on technical front with local databases, which make that more a more likely direction in the future. And also like web is starting to get plugins with more of the native APIs that are provided on Apple and Google. So you can now like push notifications from the web, for example, which is like a big thing for applications that are developing in that front. On Android, we have an APK, so that's pretty simple for most users. They can just go to GitHub and download the APK, install it. And then on desktop, it's just an executable file, or we have a bunch of distribution channels through Linux and Mac OS there. So it's not so much of a problem from that front. But I mean, that's where we're thinking from a technical perspective, because I do think that I don't think it's going to happen within the next kind of 1 or 2 years, but I do see the like nation states really starting to, I'm talking kind of Western democracies right now, because obviously it started to happen in China and Russia and stuff like that. But I don't see Western democracies going the App Store route for a little bit. I think it'll be kind of maybe 1 to 2 years in the future where that starts to happen. So I think from the STF perspective and the foundation, I think that'll start to become a push in the next kind of couple of years.
Nice. And then just broadly, what's kind of next for Session? Just kind of zooming out again and letting you talk a bit more about what you're excited to launch.
Yeah, so I kind of talked briefly about it a little bit before, but calls, for example, we're focusing on right now. So we've had calls in a beta state for a while, and they haven't kind of worked optimally. Like, sometimes you call someone, you answer, and it stays in this connecting state for a while. So, or, extended period of time where it doesn't connect. So that's a focus for us right now, is getting calls working better. Notifications, as you spoke about before, making sure that notifications always work in every single context, because notifications are extremely important for a messaging application to work properly. So I think it's really just kind of focusing in on those basic components. Another one is like our groups system that we use hasn't been perfect for a while. If you go offline for extended periods of time, or when users are kicked from a group, the key rotates, and that process is a little bit fragile right now. So that's something that we're working on to make more rock solid. It's basically like over the next 6 to 12 months, I don't see us actually introducing too many new features. It's more focusing in on the features that are already in the application and making those way more reliable, faster. Basically those things. Another thing we're working on is I was talking about before with the LokiNet integration. That's basically like taking that onion routing layer that we have in the application and completely replacing it with a new onion routing system, which is way faster. So average time to send a message on Session right now is around 2 to 3 seconds, which is obviously like way slower than your centralized messaging applications, which are usually going to take like from 50 to 200 milliseconds, depending on where the server is located. With LokiNet, we can actually, like in our testing, we've been able to get like a full onion routed message down to like 200 to 300 milliseconds. So like in the space where it's kind of competitive with a centralized messaging application. So that'll be something that comes through next year as well. And like dropping down the time to send a message is massive for users if they feel like they can just kind of send it and it's going to be reliably sent, but also like really quick as well. So yeah, I'd say like we're not focusing too much, or like the teams that are working on the session are not focusing too much on new features. It's more like making the application really good for the features that it currently has.
Nice. That's really exciting stuff. And then kind of just a fun question to end on. Outside of the project that you work on, what's your favorite privacy project?
Oh, that's a difficult question. I think we've always been like big fans of what Monero is doing, for example, like with building privacy coins. And we initially took that route as well of building out a privacy blockchain. And I understand like the technical lift that and how difficult that is. So I've always had respect for people that are working on Monero. I think another thing just on the Monero ecosystem that's very cool is there's a cross-chain swapping protocol called SECRECY, which is being developed out right now, which I think,
Luke Parker.
yeah, exactly. Which I think will potentially solve some of the issues Monero has with linking to kind of centralized liquidity sources, because right now, and I think it's going to happen more in the future, like Monero is being delisted from a bunch of different exchanges, and it's becoming harder and harder for normal users to get access to Monero or buy Monero. And something like a cross-chain DEX where people can provide liquidity and just swap with a Uniswap-like experience from Bitcoin or Ethereum into Monero without having a centralized party involved and can't be delisted from there, I think will be huge for Monero. I also work on or I'm a co-founder of another cross-chain swapping protocol called Chainflip, and that shares a lot of similarities with what SECRECY is doing as well. So yeah, those are probably some projects. I mean, there's also very cool stuff that's happening with zero-knowledge proofs on the Ethereum blockchain with projects like Railgun and Tornado Cash. So I think those are also very cool projects that are ongoing too.
Nice. Well, I really want to thank you for this very thorough interview. Definitely one of the longer ones we've done, but it's been really important to, I think, help people understand what session is, because I think it's just tough to cover everything in a messenger. There's a lot to it, and probably one of the most difficult parts is taking that a lot and making it simple and easy. So I just want to thank you for your time and everybody who tuned in today.
100%. And thanks for having me on, and thanks for doing the work that you do as well, covering all of these projects. It's really good to see someone get that voice out. And I know like a lot of these projects are very highly technical and it can be hard to get over that hurdle, but what you do with like simplifying things down, I think is, for the average consumer, I think is really important work. So thank you.
Awesome. Thank you so much. And there we have it. I want to thank Kee for coming on the podcast. It's wonderful to have so many wonderful projects join us here on Techlore Talks. If you enjoy these interviews where I get to ask some questions and get you all the information that you're looking for and get to meet the people behind some of the projects you all use and depend on, support the channel. You can do that by becoming a Techlorean on Patreon, on our own forum. You can tip us via Monero. You can do it through YouTube. You can do it through GitHub. You can do it in a lot of different places. Check out techlore.tech/support if you want to see how to support Techlore. Thank you all for learning a little bit more about digital rights today. And if you like this video, like it, share it, and spread some love and leave a nice comment down there. Thank you all, and we'll see you next time on Techlore.